Hello all, welcome to the Security Tube Python Scripting Expert course and certification. In this exercise of Module 2, we will look at how to create a simple multi-threaded TCP SYN scanner using threads as well as the Scapy APIs. Now, what I have done is I've basically taken the multi-threading example which we had seen in the course and just made smaller modifications to it. Let me run you through what I've done. So as in the previous course demo, we had the threading and the queue modules. Now let me go down below and tell you what I've done differently. Now what we are going to do is we want to insert ports between 1 to 1000 into the queue, and we want worker threads to pick up a port and then verify with a SYN scan if the port is open or closed, right? So in a very simple way, if they receive a SYN ACK, that means the port is open. If they receive a reset, that means the port is closed, right? Now, there are a lot of corner cases such as firewalls being there, which means you neither get a SYN ACK or a reset, it could be silently dropped. Now, we are not trying to solve a port scanning problem here. What we are trying to illustrate is simply how can you multi-thread an available program or API very simply using Python. So please keep that in mind. Now, what we do is we create 10 threads, right? And basically, we also create a new list called threads so that we can actually know what were the threads we created, and we append each of the workers to it after creating and starting it. In the end, what we do is we need to basically wait for all the threads to finish, and hence we iterate through the threads list and then call join on all of them so that we can wait for them to finish. Now let's get into the meat of the whole program, which is the actual worker thread itself, right? So as you guys have already probably seen in the course video, worker thread would basically be having the base class as threading.thread. Now inside init, what we basically do is that we take two arguments. One is the queue and the other is the thread ID, which is allocated by the main thread. And we go ahead and store both of these as instance variables. After this, we print that, well, the thread has been initialized and worker, whatever be the thread ID, reporting for service. Now in the actual run method, we go ahead and implement the port scan. So how does it work? Well, we initialize a variable called total underscore ports in case we want to keep track of how many ports was serviced by every thread. And then inside this, we initialize port to 0. Then we try to get a new port from the queue. Now please note that if you use self.queue.get without timeout or in a non-blocking way, it's going to block till it actually gets something. This is undesirable because if there are no more ports left, you automatically want your program or your thread to know that and probably just exit. So what we do is that if we enter a timeout feature where we say, okay, we're going to try and get the next port from the queue and wait for a second. If we do not get a new port within a second, we'll just assume that, hey, there is nothing in the queue. And when that happens, we get an exception called queue.empty. At this point, we basically print a simple statistic about how many ports were scanned by that specific worker thread and just return. Now, if we did get a port, we then move on to Initialize Kp. Now, this is very, very simple. If you remember all the different things we've talked about when we discussed Kp, we basically take in the IP address from argv1 and then we construct a very simple SYN packet. We set the flags to be S, right? The destination port to be the port we received, and the destination IP to be the IP address which we received. Now we use SR1 so that we wait for a single response, and if there is a response and inside the response the value of flags is 18. Now it is 18. Basically, if you kind of draw all the bit fields and place SYN and ACK and then actually count the value, you would actually find that to be 18. So if it is 18, we assume we received a SYN ACK, which means the port is open, and we go ahead and print that, and then we actually post a task done back to the queue, increment the number of ports, right? Awesome. So let's try this out. So let's run the multi-threaded scanner, give it an IP address. This is my gateway IP address at home. Clearly see we actually have all the worker threads initializing. They've already found 3 ports. Thread 8 actually found port 21 to be open, 123, and thread 2 has found port 80 to be open, right? Now they're still trying out all the other ports. We've given between 1 to 1000, so this would take some amount of time. But as you can clearly see that all these threads are participating together. Now, one of the things which I'd like to mention here, of course, is that a lot of how well the scanner would work will depend on Scapy's own functionality. Because all we are doing, if you think about it, is writing a wrapper over Scapy and making it multi-threaded, right? Now, if you wanted to implement your own scanner from scratch, you would have to use raw socket, capturing to receive the replies, and injection to send out the initial probe packets. Now, we see that all our 9 worker threads have now exited, and these are the number of ports which all of them have scanned as well, right? Fantastic. So that's all for this video. If you have any questions, you can post them in the student forum, and hopefully many of you have enjoyed creating the multi-threaded port scanner in Python. Thank you.